All right, we made it to Thursday. Your FRQ test is tomorrow. We're almost done with Unit 1 content. And so here we are. Just wanted to say hello again. Plan for today, you guys are going to learn about statistics as it pertains to psychology. This is probably the mathiest thing that you're going to do in psychology, right? Like actually understanding the numbers that psychologists are pulling from in order to make assumptions about what's going on in the brain and human behavior and whatnot. So just recognize this is the mathiest thing that psychology has involved in it. At the end of today's lecture, you are going to be doing another formative check to just make sure that you guys are on point with getting those little bits about stats and the basic understanding of statistics, because basically that's how we understand the world of psychology and how we study psychology. So you guys are going to do that at the end of the lecture today as you're working through practices and watching videos and whatever. Write down any questions you have. Again, it's Thursday, so we do have office hours today. So if you do have questions, if this does get confusing, I know it's a lot, especially without me being there, you can pop in and we can get those figured out for you. Good luck, have fun!
So we're going to start this lecture with actually a video to give some insight into like how important stats really is to psychology and the study of psychology. And so we'll start with that. This is a shorter lecture, especially than yesterday's, so that you have a little bit more time to work through that formative and make sure that you really do have an understanding of the statistic background of the studies and the research that we're going to be looking at. So let's go ahead and start by watching this video, The Joy of Stats. He talks about, well, the man is named Hans Rosling, and he talks about how we can use stats to understand the world, and he does so in a really visually exciting, I don't know if exciting is the right word, but like relevant way. So go ahead, we're going to watch this, and then we'll come back and chat about it real quick.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew.
So, here we go. First, an axis for health. Life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400,000, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up, Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Now that we've kind of seen that visual representation, now we know that like health and wealth aren't necessarily inherent ideas as we're talking about psychology, but I think this does a really good job of, one, giving us that visual representations of like what stats can show and how stats can further our understanding. But it also gives us some insight into like something like operational definition, right? How do you define health? This country's healthy, this country isn't. Well, this study chose to define it by average lifespan, right? That's the operational definition of a country's health. And they looked at that and you could see, right, we can talk until we're blue about the differences between countries and whatever, but until you put it onto a scatter plot graph and show it in this visual way, like we don't really have an understanding of the scope of changes that have occurred or the correlation that inherently exists, right? We can see that there is a positive correlation. As countries have a higher average income, they also have a higher life expectancy. And you can see that through this statistical representation of points on a scatter plot graph. So this is just a really good introduction into our understanding of why psychology is so important to our understanding of, why statistics is so important in our understanding of psychology. So we're going to take that and kind of cruise on and look at the need for statistical reasoning, right? At first glance, our observations might give us a misleading picture, right? If we're just doing something like a case study or naturalistic observation, right? We can kind of see some things going on, but we really can't infer causation from our own observations, right? For example, many people have a misleading picture of what income distribution in America is ideal, actual, or even possible, right? So this like American dream idea has been pretty significantly skewed and like blown out of proportion, and people view normative as way more than the average American actually has or even really needs, right? And so our observation of what normal, quote unquote, normal is isn't necessarily always accurate. So we have to recognize that. And so with that understanding, insert statistics, right? The value of statistics to present a more accurate picture of our data in this video, right? The scatter plot graph, than we would see otherwise, right? I think it was interesting when he pulled out the different countries or the different provinces of China and recognized that, like, yeah, we can look at a country, but that in and of itself isn't even a full picture of what's going on here, right? If we break down the country into provinces and then rural versus urban, right, we see differences in wealth and health, right? And so this helps us reach valid conclusions from our data and gives us like a really solid reference to recognize that statistics are crucial in terms of our understanding of psychology. So this is just kind of the basics of like, why do we need it? It may sound repetitive, but it is extremely important. Literally every single part of your psychology textbook, every content piece we're going to cover, all stems in this research. So you have to have this understanding in order to get the rest of the content. That's why we're spending so much time like continuously talking about these ideas. So obviously these square boxes didn't carry over. I just took a picture of my computer screen that I'm using as we work through these lectures. But with kind of continuing on our journey through statistics, there are 3 measures of central tendency that you are going to need to know. Hopefully, at some point in your mathematical science life careers, you have heard of mean, median, and mode. These are all measures of central tendency that you are going to have to be able to differentiate between and calculate as we move forward through this course. So just to break them down, brief description, brief definition, right? Mode is the most common or level number, or most common level number or score, right? Like, so we're looking at if you have a list of numbers and there's 13 threes, 10 fives, and 2 ones, right? The 3 is going to be the mode because there are more 3s than any other number, right? That's your mode, most common score. Your mean is the average, right? You find your average by adding up all of the numbers and dividing the score, right? Medium is the middle most number, right? And so not all of these central tendency measurements aren't going to be the same. Sometimes if a distribution is in fact normal, they will be, but generally speaking, they won't be. So let's just look at this real quick. If we have 1, 1, 2, 3, 5, 6, 8. Okay, those are our numbers. In order to find the mode, we recognize that there are 2 ones. So our mode is going to be 1. Right? Looking here, our mean, we have to add it all together. I've got my little calculator on my phone out. 1 plus 1 plus 2 plus 3 plus 5 plus 6 plus 8 equals 26 divided by 2, 4, 6, 7 numbers. Right? So we add them all up and divide by how many there are. That gives us 3.71. Okay, that's going to be our average. And then the last one is our mode. And we can find this by doing one of these. Boom, 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 boom. Our middlemost number is a 3. That's going to be our median. Again, this hopefully is review for you, but I do just want to make sure that I go over it just as a refresher. So there you have it, mean, median, and mode. You will need to know these central tendencies. So now we're going to dig a little bit deeper into these measures of central tendency and then connect them to a bell curve or a normal curve and how scores are distributed. So looking at this, we see the mode, median, and means of this family income distribution, right? Note that this is a skewed distribution, meaning a few families greatly raise the mean score. So if you're looking at this, and you're looking at like the average family income, right? Our mode is going to be $20,000, right? Because here you have the mode, this has the most people, right? That's our mode. Median is the middlemost number. So presumably whomever did this work before me in the textbook crossed off, crossed off, crossed off, crossed off, and made their way all the way to that middlemost number. But with that said, our mean is significantly higher than both our mode and our median, right? More people fall below the mean than those that fall above the mean. And this happens when you have what we call, and I referenced this idea last lecture, outliers, right? And so these, let's see if I can write a little bit better this time. These are going to be outliers, and they're going to pull the seesaw, pull that mean further towards them, right? So if you got rid of, hypothetically speaking, you got rid of just this single outlier alone, like if you just got rid of that, your mean is going to significantly decrease because this total isn't being added to our mathematics, right? This should make sense. We're going to talk about skewed distribution here a little bit more when we look at the bell curve. But for now, right, recognizing that kind of seesaw analogy that we have going on here, the income is so high for some families on the right that just a few families can balance the income of all the families on the left of the mean, right? This gets back to the video we watched at the beginning where he broke down all of the different, he looked at 2 provinces of China, and he saw that some were significantly wealthier than others, and so because they're pulling in opposite directions, that's going to impact the mean. So here we have the application of mean, median, and mode into kind of the standard statistics kind of platform. So we have these measures of variation. So not only do we measure the mean, median, and mode, those measures of central tendency, but we also can measure how far or how much scores vary from each other, right? Are all the scores really close together, all around a similar income number, or are they really, really spread out, right? And so we have range and standard deviation to help us measure this variation. Range, definitionally speaking, is the difference between the highest and lowest scores in a distribution, right? If we look back, I can't really go back to the last slide, but the lowest income was $15,000. The highest income was $710,000. And so the range, if I do my math, 710 minus 15 is $695,000 is how much we see those incomes range from. Standard deviation then is a calculation of the average distance of scores from the mean, okay? So this is probably one, if you haven't taken statistics, this is going to be a term that is probably new to your mathematical vocabulary. So standard deviation is a calculation of the average distance of scores from the mean. Looking at this image, right, your mean is this number. Let's give it an actual number just so we can reference it. Let's say the mean is 50, okay? How far scores differ from that mean if it's not a lot, if all of the scores are between, say, 40 and 60, right? There's not a very big standard deviation, right? We don't vary from the mean all that much. On the flip side, a large standard deviation would be if we have scores of 10 here and scores of 90 here, right? That range is bigger. The average that we're seeing our scores vary from the mean is going to be different, right? We're going to have more numbers, kind of scores over here, maybe some scores all bunched here, and like that. Whereas if we're looking at that small standard deviation, right? Everybody's pretty close to this mean number of 50. Yeah? Then to take that the next step, I referenced skewed distributions a couple of slides ago when we talked about the income, right? The income being at $710,000. Like there's just a few people on the really high end that skews the data and pulls that mean with it. That would be like here, we have somebody at $710,000 as on average, and here we have somebody at 15. We have a lot of people down here, right? We have a lot of people here, some people here, and one, right? While your median is going to fall somewhere over here, right? Because you have this big number here, it's going to skew your data. It's going to pull that average, right? So income distribution is skewed by the very rich. It's pulled by the very rich. Intelligence test distribution tends to form a symmetrical bell, which is more shaped like a normal curve. So here your skewed distribution is this one, right? Whereas something like intelligence, when we have intelligence testing, people tend to fall along what we call a normal bell curve, which looks a little bit something like this. That's your normal curve, meaning that if this is our average, you have a pretty consistent number of people across the entire gamut. Hopefully these dots and writings aren't too confusing for you. They're just meant as my way because I can't be with you to actually like act it out and show you, which I normally would with my hands, which you probably noticed in all my intros. I talk a lot with my hands, but this hopefully gives you some visual of that idea of a skewed distribution. Whoa, this got all wonky. So what I am going to do, we're going to make a shape here. I'm going to cover that up, and I'm going to draw you a normal distribution, right? So here we have a relatively normal distribution, right? Our mean is in the middle. That's not great. Our mean is here. And this is our normal curve. I apparently can't write very well with this iPad situation. Okay, so that's our normal curve. When we're talking about standard deviations, right, that's the average that people vary from the mean. In a normal distribution, this is going to be one standard deviation, right? Here you have two standard deviations, 2 SD, and here you have 3 standard deviations, right? With that said, looking at this portion here, 68% of people in a normal curve are going to fall between one standard deviation away from the mean. If you go out to the next standard deviation, 95% of people are going to fall within 2 standard deviations of the mean. And then the last one here, if you're 3 standard deviations from the mean, that is going to contain 99.7% of people. So 99.7% of people fall within 3 standard deviations from the mean. Now this is a little bit advanced. This we will talk in far more detail about when we get to intelligence testing, but it is important that you kind of recognize this and recognize that what a standard deviation really is, right? A standard deviation is how far, on average, scores vary from the mean, and that is going to contain a certain number of people, right? If you're within 1 standard deviation of the mean, you are part of 68% of people who are being counted. If you fall within 2 standard deviations of the mean, you're 95% of people who are being counted. And then if you're within 3 standard deviations of the mean, you're within 99.7, okay? Again, this is a little bit advanced, but it is important that you have this kind of understanding moving forward. We're going to dig a lot more deeper into this and give like specific examples when we look at intelligence testing. With that said, here is a good example of an intelligence test as kind of a representation of some of these statistical ideas. So I want you to try, with the help of this rough drawing below, which is in fact pretty rough. We'll cover that up. Ignore this little squiggly line there. Oops, I don't want that. I want black, and I want it to look like this. So if this is 100, right? Blue are intelligence test scores of high school students, right? And pink, or let's make it red, our intelligence scores at a college. What does that tell you about some of these ideas? So again, try with the help of this rough drawing that I just did to describe the intelligence test scores at a high school and a college using the concepts of range and standard deviation. Pause this, think about these terms, think about how this graph shows us these terms, and then I'll give you kind of, I don't know if this is like an answer, but we'll talk it through in just a second. Pause it, work through it yourself. So looking at this example, we notice, one, looking at range, right? The range is essentially the same, right? Our range is going from here to here, here to here. So here we have N, G, E. Okay, so we have our range, right? Basically the same. What we also notice is that oh my gosh, I can't think. The standard deviation is smaller at a college than it is, right? So standard deviation being the variation from the mean. And we know this, and we could kind of make some assumptions that it's likely to be narrower in terms of a range of intelligence test scores at a college than a high school, because at a college, people with lower intelligence scores probably either chose not to go to college or didn't get in or whatever, right? You have overall more intellectual people in a college setting than you potentially do in a high school setting. So that's one way to kind of think about it. We have one more kind of big text heavy slide with terms and ideas about drawing conclusions from data. Please, if you're taking notes, do not write all of this down. You can reference back to it if you need to, or just kind of like look at some of the bold words and make sure that you have an understanding of what they actually mean. But when we're drawing conclusions from data and we're looking at these bell curves and these scatter plot graphs, like how do we use that and make sense of it, right? The first thing we have to think about is the difference reliable? Can we use this result to generalize or predict the future behavior of the broader population, right? We know that part of achieving this reliability is non-biased sampling, right? Random sample, random assignment. We talked about that yesterday. We also know that you need consistency and that you're checking the data, the responses and observations that are not too widely varied and that they're showing some clear pattern. And then lastly, the more people you can collect information from, the more reliable it's going to be. The second piece of this is looking at whether or not the difference is significant. If you take AP Stats, or if you hear anybody ever say like, this is statistically relevant, the difference is statistically significant, right? That means that like the correlation is strong enough to be considered causation, right? Could the result have been caused by random chance? When something is statistically significant, our data is reliable and the difference between the groups is large, right? It's not just like a potential hypothetical relationship between these events or what have you. So with that, right, this is kind of the basic rundown, the 101 stats for psych. Again, you are going to, I feel like there's probably like a lot going on in your head if you haven't been introduced to some of these ideas before and how they actually apply to research, but I'm hoping that you have kind of a basic understanding so that when you jump into the formative after you watch this lecture, it's going to make a lot more sense and you're going to be like, oh yeah, now I get how to apply that. And then again, we'll make sure that all of this is cleared up in office hours. All right, then moving on, this is the last piece of the puzzle as it pertains to research strategies, this scientific attitude, statistics, all of it kind of comes together. And we have to recognize the ethics piece of psychological research and psychological studies. You'll learn that throughout this course, psychologists love mnemonic devices. They love ways to help us remember specific content. So something like I do care about research participants, IDCRP, I do care about research participants. You're connecting that and relating it to remembering. In order to deem a research study or an experiment as ethical, you have to have informed consent. You have to provide the patients or participants with a debriefing. There has to be confidentiality. It has to be reviewed by a review board, and there has to be a level of protection from harm, both physical and psychological, for those who are participating. So what we're going to do is we're going to watch a longer video clip about the most unethical studies within psychology to give us a sense of like why this ethics piece has been pushed so hard in psychological research. Yes, it is a longer clip, but it's very interesting. It gives you insight into a bunch of different psychological studies that we're going to look at in the future, but some of them are just crazy, what was done to people. And we think now, like, no way could you do that. And it's true, it's because of this ethics, this push for more ethical research practices as we kind of work through that. So we're going to watch this, and then we'll finish up with an example, and then it'll be time for you to hop on that formative.
Studying the human mind is a tricky business. There's still so much we don't know and so many questions scientists are looking to answer. But when researchers are working with human subjects, they have to balance getting answers with protecting their subjects. In the past, they haven't always been good about taking care of the fellow human beings they're studying. A lot of historical psychology experiments would be considered unethical by today's standards, and the foundation of the ethical standards we use today comes from the 1970s, when scientists came up with a list of rules to protect the security and privacy of human volunteers. It's known as the Belmont Report. Basically, 3 key ethical principles to guide all human research. The first point is called respect for persons, and it means that subjects have to give informed consent. Anyone who participates in human research, including psychological research, needs to know the risks and benefits of the experiment before signing up. The second ethical principle is called beneficence, and it basically means that researchers should try not to have any negative impact on the well-being of the people who participate in their studies. Basically, do no harm. The final point, justice, involves making sure that subjects aren't exploited. Researchers should also make sure that the burdens of the study and the benefits of the results are distributed fairly. In early research studies, for example, the subjects would often be poor, while wealthier patients would benefit from the results of the experiment. And that's not okay. These rules apply to human research in all fields, including psychology. But the code of conduct hasn't always been so clearly defined, and before it was, there were a lot of questionable studies being done. In the year 1920, a psychologist named John Watson wanted to show that humans can be classically conditioned, like what happened to Pavlov's dogs. Basically, classical conditioning means pairing a stimulus, like food, that triggers a physical response, like drooling, with an unrelated stimulus, like a bell. Even though ringing a bell, of course, wouldn't normally make dogs drool, when Pavlov paired the sound with food, he conditioned the dogs to respond to the bell by drooling. Watson and his team decided to prove that this could be done in humans by classically conditioning a 9-month-old baby named Albert using animals and scary noises. First, the researchers presented Albert with a fuzzy white rat. As he'd reach out to pet the animal, the psychologists would strike a hammer against a metal bar behind his head, creating a loud noise to startle him. Eventually, just the sight of the white rat was enough to make Albert start crying and crawl away. He'd begun to associate the fear of the loud, scary noise with the fuzzy white rat. So yeah, Albert had been conditioned. But this study failed in a lot of ways. For one thing, it used a single subject and no controls, so Watson hadn't really proved anything. But then, of course, there were the ethical issues. Watson never reconditioned Albert to not be afraid anymore, so he was permanently affected by the experiment and not in a good way. We also don't know if Albert's mother fully consented to the research, which definitely violates the main ethical principles of the Belmont Report. And this wasn't the only horrifying psychology experiment conducted on children in the early 20th century. In the late 1930s, a psychologist named Wendell Johnson and his graduate student Mary Tudor at the University of Iowa wanted to know how positive and negative feedback affected the way children learned language. They decided to test this directly by giving kids positive and negative feedback on speech disorders. That might not sound so bad, but there's a reason why their experiment is now known as the Monster Study. Tudor recruited 22 children from an orphanage, told them they'd be given speech therapy, and split them into 2 groups. 10 of these children, 5 in each group, had early signs of stutters, but both groups also included kids with normal speech patterns. The kids in one group were told that they didn't have a stutter. They were given positive feedback that they'd outgrow the speech difficulties and that they should ignore anyone who criticized the way they spoke. Meanwhile, those in the other group were told that they did have a stutter and that they should never speak unless they could do it right. As you can probably imagine, this didn't go very well. The encouragement and criticism didn't seem to have much of an effect on the children's stutters, but the different kinds of feedback did have a huge impact on their self-esteem. The kids with speech issues who got positive feedback didn't lose their stutters, but they did become a lot more confident when they spoke. Meanwhile, the children who were given negative feedback became more withdrawn, self-conscious, and frustrated, whether or not they actually had a stutter to begin with. So for that group of kids, this research was pretty damaging. As minors, they couldn't consent to the research, and the people who ran the orphanage didn't protect them from the potential harm of the study. The children also weren't debriefed after the project was over, and there was no real follow-up on how they may have been affected by the study long-term. All of these things were later declared unethical by the Belmont Report. Experiments, of course, can harm adult subjects too. In 1961, a researcher at Yale University named Stanley Milgram was interested in the psychology of obedience. He decided to see how subjects would react when a researcher pushed them to do things that went against their morals. The study he came up with is now called the Milgram experiment, and it had 3 separate roles. The experimenter, played by a scientist in a white lab coat, was the authority figure. The teacher was the role assigned to the experimental subject, and the final role was the learner, a paid actor who the subject thought was actually another volunteer. The learner was sent to a separate room so they were out of sight while the experimenter observed the teacher, the subject, instructing the learner in a word pairing task over an intercom. Every time the learner got the word pair wrong, the teacher pressed a button to shock them, with the voltage increasing by 15 volts for every wrong answer. The subject believed they were shocking the learner, but they were actually listening to an actor pretending to be in pain, complaining of chest pains, shouting, pounding on the wall, and eventually going silent. The experiment only ended when the teacher had given the maximum 450-volt shock 3 times in a row, or when they refused to continue. 65% of the subjects did give out those maximum voltage shocks, just because a scientist in a white lab coat told them to. Milgram concluded that people will obey authority figures even in morally questionable circumstances, and the experiment has since led to many more studies on the psychology of authority. But the subjects thought they were actually listening to someone being electrocuted on the other end of the line, even though they were told by the experimenter that there would be, quote, no permanent tissue damage. Leaving your subjects feeling like they may have just killed someone doesn't protect their well-being. And they couldn't have gotten informed consent, since warning participants about the experiment would have changed how they reacted. And since then, there have indeed been other studies that led people to believe they might be hearing someone get seriously injured. In 1964, a woman named Kitty Genovese was murdered. At the time, newspapers reported that there were more than 30 witnesses to the murder and that none of them called the police. We now know that those reports were flawed, but for a while it seemed like dozens of people just stood by while someone was murdered right in front of them. So in 1968, psychologists John Darley and Bibb Latané at Columbia University came up with a way to learn more about about why people might not act in a crisis, especially if there are others around. They placed college student volunteers alone in rooms, gave them headphones, and told them that the study was about the emotional issues faced by students. Each subject was told that they would be communicating with a few other students over intercom to avoid any privacy issues that might come up if they were face-to-face. But the other students on the line were actually recordings, and one of those recorded students mentioned early on in the conversation that they had occasional seizures. Later on in the experiment, that voice would start to have trouble speaking and ask for help, saying they were having a seizure. The researchers then measured how long it took the subjects to go look for help. They found that it took participants longer to respond when there were more people in the conversation. The subject was less likely to do something if they believed there were other people who could intervene instead. It's called the bystander effect. Understanding this response is important for investigating crimes and for protecting communities by teaching people to act during a crisis instead of assuming that someone else will do it. But like the Milgram experiment, there are ethical concerns about how this research might have affected the subjects after the study was over. These days, it would be tough to convince a review board that the potential benefits of this kind of study outweigh the risks. Another study turned out to be so damaging that it had to be ended early. In 1971, Philip Zimbardo, a psychology professor at Stanford University, wanted to learn more about how being placed in different social roles affected the way people behaved. He decided to simulate a prison and cast volunteer subjects into the roles of guards and prisoners. 24 white male college students were recruited into the study and separated into two groups, prisoners and prison guards. Zimbardo acted as the prison superintendent. The prisoners were searched, then given ID numbers instead of names to dehumanize them. Meanwhile, prison guards were given uniforms and clubs and told to do whatever they had to do to maintain order, giving them power over the prisoners and a sense of superiority. The study was supposed to last for 2 weeks, but was actually called off after just 6 days because the conditions in the prison went downhill so quickly. One prisoner had to be released from the study even earlier because the conditions in the jail made him panicked and disoriented. Other prisoners started a revolt because the guards had treated them so badly. After that, the guards became more and more abusive, giving the prisoners physical punishments when they misbehaved, like forcing them to sleep on concrete and to strip naked. In the end, Zimbardo concluded that the subjects had internalized their assigned roles. The prisoners became submissive, while the guards became aggressive and abused their power over the prisoners. You could not do this study today. By acting as the superintendent, it was impossible for Zimbardo to stay impartial. That's a pretty big flaw in the study's design. He was invested in the outcome of the research. Zimbardo also allowed the guards to subject the prisoners to serious abuse and may have caused them real permanent harm. So again, that whole well-being thing was not really taken into consideration for this study. Like the rest of the studies on this list, the Stanford prison experiment would not be considered ethical these days. But psychology's sometimes dark past has helped scientists realize that they have a responsibility to protect the public and the subjects of their research studies, which is why ethical standards are an important part of modern research. We want to understand the human mind, but in the process, we also have to protect the minds being studied. The standards laid out by the Belmont Report help us do just that. Thanks for watching this episode of SciShow.
So there you have it, Hank Green talking about psychological studies and the lack of ethics and some of the more famous ones. If any of you have taken U.S. history or APUSH, you have definitely watched Crash Course U.S. History with John Green. This is Hank is his brother. I don't know, I just went off on a tangent. That happens. It's kind of weird to do it when I'm not with you guys and I'm sitting behind a computer screen, but whatever. Let's move on and look at ethics and put that to the test and just look at an example. So here's the example. Feel free to pause the lecture, read through it, and then I want you to think back to that acronym. I do care about research participants, right? Looking at informed consent, debriefing, confidentiality, having a review board, and protection from harm. And I want you to tell me how this particular example breaks the ethical guidelines of psychological studies. So pause it, read it, and then determine where are we seeing lack of ethics. So here's your answer. Right, you've looked at it. We know that with this professor's study, there is no evidence of an internal review board. Nobody is like cross-checking the research that this professor is doing. There's no informed consent. There's no assurance of confidentiality, at least not explicitly listed in this particular example. There's no not necessarily protection from harm, right? We don't know the impact that this particular survey or questionnaire will have on their mental health. And then the lack of evidence for debriefing. Like it doesn't explicitly state that the professor goes back and talks to his participants and tells them the purpose and tells them why they were a part of the study and what the goals were and what the research was looking at. So with that, that's kind of all I have for you. And it's a brief, again, big picture overview of statistics for psychology. Go ahead and make sure you feel comfortable with all of these ideas. Make sure that you feel comfortable with these components to ethical practices. Yeah.
So there you have it. You learned statistics. Next up, hop on Canvas, check out the formative check again. Please remember, you have an FRQ tomorrow. We have office hours today at 2 o'clock. So if you're like, what is an FRQ? It's a written essay question. There's actually 2 of them that you're going to have to answer. And that is going to be via Canvas. You're going to have to write it out. You're going to have to understand all this content from Unit 1 and be able to apply it. So if this is something that's worrisome to you, or if you have questions about it, feel free, again, hop on during our office hours or shoot me an email, whichever is easiest for you, and we'll get it figured out and make sure that you are prepared for tomorrow's FRQ test. Okay? So enjoy the rest of your day. Again, hop on, do the formative for stats to get your participation points for this unit. I'll be around. If you have any questions, I'll be here. Later.